Hi, and welcome back to Algebra 1. Our goal for today is to continue working with solving our systems of linear equations using the elimination method, or I'm aiming to eliminate x, or I'm aiming to eliminate y in step 2, or box number 2 of my work, by getting opposite coefficients on either my x variable or my y variable. So at this point, I should be an expert with using the graphing method to get my solution of a system, using substitution method to get my solution to a system. And today we are going to continue with our third option for solving, which is I'm eliminating x or y to help me solve the system. And the way that we do that is getting opposite coefficients on one of our variables. Please remember there's three different things that could happen. I could end up with exactly one solution. Right, that's what's going to happen the majority of the time. I end up with an ordered pair of an x comma y. I never get stuck in any of my boxes while I'm solving. I get to an x equals something and a y equals something, and I can check to make sure it's the proper solution. Option 2, though, I might have lines that are parallel. So I need to know what that might look like in my steps of work that would cause me to have parallel lines where there are no real solutions, right? There's no place that satisfies both those lines, so we'd have no real solutions. And the way that I tell is in box 2, I end up with a false statement with no more variable left, like 10 equals 8. And I would say, wait, no, it doesn't. That's not equal to. So I have no real solutions, which would indicate in picture form that the lines would be parallel to each other. We can also have a line that coincides with another line. Fancy way of saying a line on top of a line. When that's the case, there are an infinite amount of solutions. Remember, that is not the same as all real, so make sure you're specific when saying infinite, not all real. And the way that I can tell when I'm working through my boxes of work is in box number 2, I'm going to end up with a true statement that does not have a variable, something like 10 equals 10. That's true, which leads me to, then there's an endless amount of solutions called an infinite amount of solutions. All right, so picking up where we left off in our previous lesson, example number 4 using our elimination method. All right, you want to solve the system of equations 2x minus y equals 16 and 3x plus 5y equals 11. Now, everything's lined up. X's are lined up, Y's are lined up, numbers are lined up, so we're good here. We don't have to do any rearranging to get them set up and ready to go. Now, we do not have opposite coefficients on anything. So I would look and say, all right, can I get 2 easily to its opposite coefficient of 3? Well, not really. Can I get this negative 1 that's here with y to be an opposite coefficient of this positive 5 fairly easy? Yeah, I can. I could take this top and multiply it by 5, and I would end up with opposite coefficients. So my suggestion for this one is to deal with the y's and take that top equation and multiply it by positive 5, because that's going to give you opposite coefficients on your y variable. All right, so let's attack it. We're going to take 2x, the whole thing, 2x minus y. We're going to multiply it by 5 equals 16. We need to multiply it by 5, right? Well, we do to one side, we got to do the other. So we're taking this equation, just rewriting it in a slightly different, sort of unsimplified version. When we do that, we end up with 10x minus 5y on the one side. 16 times 5 would give us an 80 on the other side. All right, so now we're going to use that over here in place of this top equation, or this first equation. So 10x minus 5y equals 80. All right, we're going to use this second one with it. 3x plus 5y equals 11. All right, we're going to stack them up and add them up. All right, 10x plus 3x would give us a new amount of 13x. Negative 5y plus 5y will eliminate, and that's our goal. Get opposite coefficients so you eliminate either the x or the y from the problem. 80 plus 11 would give us a 91. All right, one stepper from there. We're going to divide both sides by 13. When we do that, we'll see that we have an x value here of 7. All right, so we think our solution is at 7, we're not quite sure yet. All right, we're going to use this 7 to help us solve for the y. I can use either of these two original equations in step number 3 and substitute in our x we just solved for. So I don't know, let's use that first one. 2x minus 1y equals 16. All right, we're going to take our x and substitute it in. So 2 times 7 minus 1y equals 16, or 14 minus 1y equals 16. All right, we need to get rid of this positive 14 that's here first by subtracting a 14 from both sides. All right, we'll have a negative 1y equals 2. All right, from there we need to divide everything by negative 1, which will give us a y of negative 2. So we think our solution is 7 comma negative 2. So our last thing, I should be able to get 100% on a quiz for these because I can go back and check to make sure I did my work correctly. 2 times 7 minus negative 2, would it actually give us a 16? All right, so right here we'd have a 14 minus negative is just plus positive 2. So I'm going to go ahead and do that keep change there. That might help us a little bit see that. Yep, we do get 16 equals 16. All right, over here we'd have 3 times 7 plus 5 times negative 2. Would it actually give us an 11? So 21 here. Negative 10 here. Would that add up to 11? And yep, it sure would. So 7 comma negative 2 is our final solution of that particular system. All right, number 5. I want to solve the system of equations using elimination method when we're given 3x plus 2y equals 8 and 2y equals 12 minus 5x. Now, we're not lined up. X's, y's, numbers, right? We don't match. So we want to get this bottom equation in its standard form. So we need to do some rearranging over here by adding a 5x to both sides. We have 2y. We're going to add 5x to it equals 12 minus 5x plus 5x. And so we end up, and then I'm going to flip-flop to get that standard form. We end up with 5x plus 2y, and the whole thing equaling 12. And now our system would look like this. 3x plus 2y equals 8. All right, because this one was good. And so I just brought it back down here. All right, now we can look at our coefficients and see where would be the easiest place to get opposite coefficients. Think in your head right now, what would you do to get either opposite coefficients on x or opposite coefficients on y? There's definitely an easier one to do. In this case, it would be easier to deal with our y's. They already match, but we need one of them to become a negative. So we can either take this top equation and multiply it by negative 1, or we could take this bottom one and multiply it by negative 1. One or the other, not both, right? We just want one of those to become negative. So what I'm going to do is I'm going to work with, let's say I'm going to take this bottom one, 3x plus 2y equals 8. I'm going to multiply it by negative 1, and I'm going to keep that 5x plus 2y equals 12 the way it is. All right, so in block 1, but I could have done that times negative 1 with that other one. All right, so I'm going to take my 3x, the whole thing, 3x plus 2y, and I'm going to multiply that by negative 1, and the 8 needs to get multiplied by negative 1. All right, distribute over here. We'll have negative 3x minus 2y equals negative 8 when we multiply here. All right, so that's taking the place of this first equation. All right, so that's what we're using here. Negative 3x minus 2y equals negative 8. And then we still need that bottom one that we rearranged. Remember, we kind of reordered this one to being a 5x plus 2y equals 12, right? That was our rearranged version we did right here. That's the one we're going to stack up there. All right, we're going to add those up. Negative 3x plus 5x would give us a 2x. Negative 2y plus 2y will eliminate. That's our goal. Eliminate either the x or the y. And then back here, our negative 8 plus 12 would just give us a value of 4. All right, one step from there, we're going to divide both sides by 2 to get that our x value is a 2. All right, we think our solution is at 2 comma something. We're just not quite sure yet what. I'm going to go ahead and use this guy, bring it over. 3x plus 2y equals 8. Again, I could have used the 2y equals 12 minus 5x. I can use either of the originals. I'm taking this x equals 2 and substituting it in to solve for y. So 3 times 2 plus 2y equals 8, or 6 plus 2y equals 8. Two-stepper, start with subtract 6 from both sides and start chipping away. We want to get that 2y by itself. So 8 minus 6 will give us 2. And then we'll finish here by dividing both sides by 2. And we'll see that our y value then is a 1. So we think our solution is at 2 comma 1. So we're going to take our x of 2 substituted in, our y of 1 substituted in, make sure we get 8 equals 8. Then we're going to take our x of 2 substituted in here, our y of 1 substituted in here, and make sure we end up with 2 equals 2. In this case, we have 8 equals 8 and 2 equals 2. When we run our checks, our final solution is 2 comma 1. All right, I hope that helps you attack your work for today. See you guys later.